Hey guys, welcome to another video for AP Chem, and this one we're going to be looking at big idea 3. So there we go, idea 3. All right, so big idea 3, let me go ahead and read it for you, is changes in matter involve the rearrangement or reorganization of atoms and the transfer of electrons. So really just chemical reactions. And so big idea 3 should be a good bit of a review for you. But just because it's important to sort of hit all these things and make sure you do know them, some things in big idea 3 you're going to need to know. Types of reactions, okay? So we'll go through those real fast and should be, like I said, review for you. All right, so the first type of reaction we want to talk about is synthesis. So let's look at synthesis. Okay, so synthesis reactions are when any simple compounds or even elements are combined to form, a more complex one. So, if you had, if you took and you bubbled oxygen gas through solid magnesium, what are you going to get? Well, you're going to get some magnesium oxide, right? And that would be a solid. So synthesis, so you see the two things becoming one thing here, piece of cake. Decomp would be the exact opposite of that. So actually if I was to degrade this and break this apart into a solid magnesium and oxygen gas, that would be my decomposition. So decomp is where you have a complex molecule and it splits apart. So you think of decomp as the opposite of synthesis. So we have synthesis, we have decomposition, we have one of our all-time favorites, the acid-base reaction. All right, an acid-base reaction is simply where you have something that donates a hydrogen react with something that donates a hydroxide, and they form water, right? And usually some kind of a salt. So, for example, if we took the classic HCl plus NaOH, two strong bases, what do we get? Well, we get water and salt, right? So, this is kind of our basic acid-base reaction. So acid-base reaction, the main thing is going to be taking these two ions, making water. We have a couple other ones, but these are kind of the main ones you're going to have to look out for. So synthesis, decomp, I should probably write decomposition in here. Decomposition, and I just went over it quickly as the opposite of synthesis. All right, so and then the other one that will come up a lot is the oxidation reduction reaction. Okay, oxidation reduction reaction. So, so in this one, what we're going to do is we're going to look at, sorry about that, we're going to look at the transfer of electrons. So, if you're looking at like a, like a battery or some kind of electrochemistry sort of equation, you're going to often see something like this, where you have like copper, and then copper is going to be reduced, so we're going to add some electrons to it, and then we're going to end up with copper in the solid form. So you could have an ionized copper in solution and add some electrons and it becomes solid. And so that's kind of what happens on one of the ends of our battery or our galvanic cell. And some other equations that come up are going to be like combustion. So combustion is anytime you combine with O2. So if I have something with O2, and typically combustion reactions create CO2 plus water. So that's kind of an easy one to predict. And you're looking for the combination of O2, not just oxygen, because there's an oxygen in lots of things, but O2. And you might say, well, then is this a combustion reaction? It might qualify as one actually, but it is a synthesis as well. So sometimes you have like kind of a little bit of crossover here and there, and actually oxidation reaction occurs in many equations. So you'll be asked to identify that in a ton of different equations. All right, so let's go through, you know, just kind of some basics of chemical equations and stuff. And so balancing chemical equations is always a big deal, and it's always something that that they like you to be able to do. So let's just take and look at like an acid-base reaction. So if I had hydrobromic acid, actually this isn't an acid-base reaction, sorry. If I had hydrobromic acid and I combine it with solid zinc, it's going to produce zinc bromide and hydrogen gas. Okay, so so then we're looking at balancing this, and so this is the sort of rules that I always do for balancing. Is I take and I leave the oxygens for last, and then the hydrogens for second to last. So in this one we have hydrogens, we don't have oxygens. So what I'm going to do is I'm going to start with the zinc. Okay. And so you can start with all the other elements and what you're going to do is you're going to make sure you have the same amounts on either side. And if you don't, you're going to add a coefficient in front. So I have 1 here, so that's good. Now if I look at the bromine, I have 1 here and 2 here. So in order to balance this, I'm going to have to put a 2 on this side. See, 2 bromine, I can put this 2 in front. But that also, when you put a 2 in front, what you're saying is I have 2 HBRs, right? And you're saying I have actually 2 of these. So that makes 2 hydrogens as well. But this is good because over here we learned that we have 2 hydrogens on this side. So now this is balanced. That's a very, very easy question to balance. So balancing equations is not hard. Let me see if I can quickly find something that's a little bit more complicated on the balancing equation side. Yeah. I can't. I'd have to look in a different book, but that's simple enough, and this is review for you guys, so not a problem. Solving chemical equations is a process called stoichiometry, and so stoichiometry is the process of basically establishing the law of conservation of mass. Right? And so the law of conservation of mass tells us that whatever comes in is what's going to come out. So in the next video, I'm going to do a couple of stoichiometry problems, and if you want a little bit of review on your stoichiometry, check out the next 2 videos. If not, you can probably, you know, skip ahead, and we're going to go into some of the energy changes in reactions and look at how heat changes from one thing to another in enthalpy, and talk about you know the graphs and sort of charts that go along with that. And then we'll look at oxidation reactions, okay? And then finally we'll get into some electrochemistry.